In this problem, we want to predict products with phases. We want to balance the equation and write complete and net ionic equations. Before we do this problem, it's a good idea to go back to your notes. Go read the notes on double displacement reactions and the solubility rules. So what we have here are the reactants. Silver nitrate, AQ, stands for aqueous. That means that silver nitrate is in solution. And this solution will react with another solution of sodium chloride. Notice sodium chloride has the same phase, AQ, for aqueous. So what we want to do first is predict those products. This is where we implement this double displacement type of reaction. So usually when we have these solutions with these ions present, when they mix, usually they'll undergo this double displacement process. And so an easy way to remember this is just swap those anions. And so the first thing we'll do is we'll identify the ions present. And so the silver nitrate, remember there are silver ions present and there are nitrate ions that are present. In the sodium chloride solution, there are sodium ions present and there are chloride ions that are present in solution. So let's swap those ions and write the products down. So on the product side, here's the silver, but instead of the nitrate, I'll write a chloride ion. And the other product will be the sodium, but instead of the chloride, I'll write the nitrate ion. Now notice that I'm writing the ions with those charges. So now what I want to do is write the formula. So what does a silver ion and a chloride ion, when they combine together to make this ionic compound, how would we write that formula? So remember back to our writing formulas, we want those charges to balance. Silver's a +1, chloride's a -1. So those charges do balance. So the silver chloride would look something like this. AgCl. Sodium nitrate. Sodium's a 1+, nitrate's a 1-, +1 -1. Those charges balance. So the formula for sodium nitrate would look like this. Next, let's write the phases. You'll have to go to the solubility rules, which you can find in your notes, and you'll see that if you follow the chloride on that chart, you'll notice that chloride is soluble with most ions. One of those exceptions is silver. So when you see a silver chloride, this is slightly soluble or insoluble. That means that it forms a solid. It does not dissolve in solution. So I write that S there to indicate that silver chloride is a solid. The sodium nitrate, if you go to the solubility rules, you'll see that the nitrate is soluble with pretty much anything. And furthermore, on those solubility rules, you'll notice that the sodium, again, is soluble with pretty much anything. So next to the sodium nitrate, I'll write AQ. So we've predicted the products and we've written down the phases. Now balance the equation. If you look carefully, of course, you'll notice that everything is balanced already. So the mole-to-mole ratio for these species is all 1:1. Okay, so this is called the formula equation. It's called the formula equation because we're writing the equation using the formulas for all these compounds. Now that's fine, and we'll use this formula equation when we do stoichiometry. But there's some other things that are important to us. The complete and net ionic equations. So let's write the complete ionic equation first. In the complete ionic equation, the thing to remember is we want to write all of these species the way that they would look in solution. Let's start with the first species, silver nitrate. Silver nitrate is aqueous. That means that this is the way we write the formula, but this is not the way silver nitrate exists in solution. Because it's aqueous, it actually exists as silver ions in solution and nitrate ions in solution. And notice that I wrote 1 silver because in the balanced equation there's 1 mole of silver nitrate. So when 1 mole of silver nitrate dissociates, there's 1 mole of silver and 1 mole of nitrate. For the sodium chloride, aqueous, again, we'll go ahead and write those ions that are present. There's 1 mole of sodium chloride in the balanced equation, so we'll write 1 mole of sodium and 1 mole of chloride. On the product side, silver chloride is solid. So silver chloride does not dissociate when the solutions are mixed. Silver chloride is produced and it's in the solid phase. So for solid, we'll go ahead and leave the silver chloride together because that's the way it is in the end. The sodium nitrate aqueous, we'll go ahead and write it as sodium plus AQ. And I'm running out of space here, so I'll write the nitrate down here. So the sodium nitrate is split up because it's aqueous. So in the end, after all of this is mixed, this is what we get. The sodium and the nitrate are in the aqueous phase. This is the complete ionic equation because it gives us a complete picture of what's actually in solution. Now, the net ionic equation. The net ionic equation, just like a math problem, is we cancel out what appears on both sides. Whatever's left over is the net. So look at the yield sign, and then on either side of the yield sign, notice what appears on both sides. The sodium aqueous is present on the reactant side. Notice that in the end, after everything has mixed, we still have sodium aqueous. You also see the nitrate. It's aqueous at the beginning, and then after the solutions have mixed, the nitrate is still aqueous. So the sodium and the nitrate don't do anything. Those are called spectator ions. Spectator ions because they don't do anything. But look at this. The silver aqueous and the chloride aqueous are not present on the product side. Yes, there's a silver chloride solid, but this is not silver aqueous and chloride aqueous. The silver chloride is together. So notice that the silver chloride do not cancel each other out. So the net ionic equation is we write down what's left over. So just so there's no confusion here, the net ionic equation is this. The sodium and the nitrate are spectator ions. So quick recap. We identified the ions present so that we can do this double displacement reaction and write the products. We use the solubility rules to include the phases, and we balance the equation. That's called the formula equation. By identifying those species that were aqueous to begin with, we wrote the complete ionic equation. The solid species stays as a solid in the complete ionic equation. By canceling out what appears on both sides, we were able to cancel out the spectator ions. Whatever was left over is our net ionic equation. So this is the chemistry. This is what actually happens when silver nitrate and sodium chloride solutions mix together.